We have another problem using Castigliano's theorem, but we are going to determine the slope of the beam shown at 4 meters from left support. So, our beam is a simply supported beam with a span of 10 meters with a uniform load of 24 kilonewton per meter. We will use the modulus of elasticity of the beam, which is equal to 200 gigapascal. And the moment of inertia is equal to 240 times 10 to the 6 mm to the 4. Using Castigliano's theorem, in finding the slope, we have this formula. So we have slope, that is the integral of the partial derivative of the moment divided by the partial derivative of the couple moment times moment over EI times dx from 0 to L. Okay, so we are going to place our couple of moment at the point where we gonna determine the slope. So in this problem, we are going to determine the slope 4 meters from left support. So if this is our support A and this is our support B, okay, 4 meters from support A, so we will assume this is our 4 meters. We let this one as our point C. We will put a couple of moment M at point C. So here, this is also 6 meters from support B. Then we have our reactions R1 and R2. Okay, we will take summation moment at each support to determine the reaction. So first, we have to take summation moment at A equal to 0. So you have 10 R2, okay, minus couple of moment M is equal to 24 times 10 times 5. Okay, so your R2 is equal to 24 times 10 times 5, that is 1,200. Then you transpose the couple moment M to the right side, so it becomes positive, that is plus M all over divided by 10. So our R2 will be equal to 120 plus M over 10. Okay, so for summation moment at B, summation moment at B equal to 0. So your R1 times 10, okay, minus M plus M is equal to 24 times 10 times 5. So R1 is equal to 1,200 minus M all over divided by 10. So to simplify, you have 120 minus M over 10. So this is your R1 and R2 reactions. Okay, we need to check if our R1 and R2 are correct. So we have to check all forces vertical equal to 0. So you have R1 plus R2 is equal to 24 times 10. So R1 is 120 minus m over 10. Okay, plus R2, that is 120 plus m over 10. And that is equal to 240. So 120 plus 120, it is equal to 240. So you have this equal to 0. So the left side is equal to the right side. So all are equal to 240. So we can say that the value of our, or the equations for our R1 and R2 are correct. Okay, so next, we need to cut or to determine the moment for the segment A and C. So, okay, you have here from A to C. So, this will be your beam. So, this is your R1. That is at any value of X. So, this is your moment. Then you have there 24 kilonewton per meter. So, moment is equal to R1 times X minus 24 times X over 2. Okay, so you have R1 again, that is equal to 120 minus m over 10. 120 minus m over 10 x minus 20, okay, 12. Okay, 12 x squared. So we have to simplify this. That is equal now to 120 times x minus m over 10 times x minus 12 x squared. So this will be our moment from A to C. For the partial derivative of the moment, so the partial derivative of the couple of moments, so you have to look at the term in the equation containing m. So we only have, okay, that is equal to x over 10. So that is negative x over 10. So from B to C, okay, from B to C, if we have to cut the beam from B to C, so we have this one. Okay, at any value of x. So it can be okay, this will be your beam. This is your R2. Okay. So you have there your moment. Okay. So we have 24 kilonewton per meter. So our moment from B to C is equal to R2x minus, okay, (24) x times x over 2. Okay, so we have R2. R2 is 120 plus 10. Okay, of 120 plus m over 10. So x minus 12 x squared. Okay, so okay, we can simplify this one. You have 120x plus mx over 10 minus 12x squared. So this is our moment. And for the partial derivative of the moment divided by the partial derivative of the couple moment is okay equal to x over 10. So we already have our equations. So we will set setting m equal to 0. So because we don't have the couple of moment at point 4, or I mean at point C, or 4 meters from the support A. So we don't have the couple of moments. So our moment couple moment m is equal to 0. So we will substitute this to our equation. The equation of the slope is this one using Castigliano's theorem. So we have to substitute all of this to our formula, and I have to transfer the EI to the left side. So I have here EI times theta C, that is equal to the integral of 0 to 4, that is from A to C. So the moment is equal to 120x minus mx over 10 minus 12x squared. Since m is equal to 0, what is left is only 120x minus 12x squared. Okay, times the partial derivative of the moment over the partial derivative of the moment couple, that is negative x over 10. Okay, x over 10 dx. Then you have to add, okay, that is from 0 to 6. Okay, that is from B to C. Okay, so the moment is 120x plus mx over 10 minus 12x squared. So m is equal to 0. What is left is 120x minus 12x squared. So the derivative, partial derivative of the moment over the partial derivative of the couple of moment is equal to x over 10 dx. So we have to simplify this one. So our equation will be written like this. Okay, 120 negative 120. Okay, that is already divided by 10. So that is 12 negative 12 x squared. Okay, negative 12x squared minus 1.2 x cubed, okay, dx, okay, plus 0 to 6. So you have 12 x squared minus 1.2 x cubed dx. So this is in the form of the integral of u to the n du. So the integral of u to the n du, this is equal to u to the n plus 1 over n plus 1. So we have, okay, this will become negative 12x cubed over 3 minus 1.2 x to the 4th over 4. Okay, that is from 0 to 4 plus 12 x cubed over 3 minus 1.2 x4 over 4. That is from 0 to 6. So we can write again this one. So this will be negative 4x cubed minus, okay, that is 0.3, 0.3, okay, 0.3 x to the 4 from 0 to 6 plus 4x cubed minus 0.3 x to the 4 from 0, okay, 0 to 6. This is 0 to 4. 0 to 4. Okay, so we can have this one, negative 4 for the 4 cube minus 0 minus 0.3 times 4 to the 4th, 4 to the 4th minus 0 plus 4 times 6 cube minus 0 minus 0.3 times 6 to the 4th minus 0. So we can simplify this one. So we have negative 4 times 4 cube. So it can be 4 to the 4th. So that is negative 256 minus 0.3 times 4 to the 4th equal to 76.8. Okay, plus 4 times 6 to the cube. Okay, that is 864. Okay, minus okay, this is correct. Is this correct? Negative, negative. So you have there. So this is positive, right? That is positive. Negative 12 times negative x over 10. So I got wrong. That is positive. So this is also positive. Okay, this is positive. Then we will go back 0.3 times 6 to the 4th equal to 388.8. So we have to add, okay, negative 256 plus 76.8 plus 864 minus 388.8. Okay, the answer is 296. So this is our slope at C. So the unit is in kilonewton per kilonewton meter square. Okay, so since our E and I are given, okay, E and I are given, so we have there 200 GPa for our E and 240 times 10 to the 6 for our moment of inertia. So we have theta C is equal to 296. So we will convert kilonewton meter squared to Newton mm squared. So we have to multiply this by 10 to the cube. Then the 200 GPa is also equal to 200,000 Newton per mm squared. So times I, which is 240 times 10 to the 6. So therefore, the slope at C is, okay, 296 times 1,000 to the cube divided by 200,000 divided by 240 to the power of 6. So that is equal to, okay, 0.006167. Okay, this is in regions. Or you can convert this into degrees, and this is equal to 0.006167 times 180 divided by 3.1416. So that is equal to, okay, or 0.353 degrees. Okay, this is our answer. And thank you for your time, and I hope you understand.